Math is one of the essential things you need to know in life. Obviously, some skills you use more than others. However, there's no job in the world today that doesn't involve some sort of math. The topic we are covering today is slope. There are several things that involve slope that we see in everyday life. Here's some pictures that you may not even realize. Although we look at slope on a smaller scale in the classroom, architects, building designers, engineers, and electricians all use slope in their job and in the things they create. We also see naturally occurring slope in things such as hills and mountains. So, the definition of slope. Make sure to write this down somewhere so you will remember it. Slope is the ratio meaning the two numbers that are proportional to one another like in a fraction, the ratio between vertical and horizontal run between any 2 points on the same line. The equation we use for slope is vertical rise over or divided by horizontal run. Some real life examples will help you learn slope better. Think of a time that you've gone sledding and how after you slide down, you have to walk back up, dragging your sled behind you. Well, the reason that sledding is so fun is because the hill has slope. Without slope, your sled wouldn't go anywhere, you would just be sitting on flat ground. So if you have a hill that is 40 feet tall and 200 feet at the base, we take the vertical rise divided by the horizontal run and come up with the slope of the hill. In this case, we get 40 over 200, or 1/5. The formula for the slope of the line can be applied to a pair of points x1, y1, and x2, y2. When thinking about the formula rise over run, you want to make sure when choosing your points that x2 is greater than x1. This way you will get a positive distance corresponding to the actual run. Think about graphing a line. You would choose 2 points on a line and use this formula to find slope. From your first point, take the y value and subtract it from the y value of your second point. Do the same with your x values, x2 minus x1, and take the change in y over the change in x. Note that you don't want your x values to be the same because then you'll get 0 in the bottom of your ratio and it would be undefined. Now we're going to look at different types of slope and calculate each one so you can see how they change. Here we've picked 2 points on the line, 1, 0, and 3, 4. Find slope by plugging in the numbers to the formula. y2, which is 4, minus y1, which is 0, divided by x2, which is 3, minus x1, which is 1. And we come up with 4 divided by 2, which gives us 2. There's a positive slope of 2, therefore the line rises from left to right. Make sure you understand where we get the points from and why we subtract the first point from the second point, and if not, then you need to ask. If you were to subtract them the opposite way, in this case, y1 minus y2 divided by x1 minus x2, you would get a negative divided by a negative, which would give you a positive number anyway, so in this case, we're just saving ourselves from having to deal with negative numbers. Now try the same technique with these points. With negative slope, subtract y2 minus y1, 1 minus 3, and you get negative 2. x2 minus x1, 4 minus 0, and you get 4. So negative 2 divided by 4, reducing to negative 1/2. There's a negative slope, therefore the line falls from left to right. Now think in terms of that sledding hill you like to go down. We figured out that a positive slope goes up and a negative slope goes down. When you're sledding down the hill, are you sliding down a positive or a negative slope? It would be negative because the side of the hill is falling. However, when you're walking back up the hill, are you walking up a positive or a negative slope? Positive, because now you've turned around and have to walk back up the hill that you just slid down. Here we are going to look at zero slope. More or less, the ground you walk on every day has zero slope, or a slope so tiny we don't even notice it. So y2 minus y1, 2 minus 2 gives you 0, and x2 minus x1, 4 minus 1 gives you 3. 0 divided by any number gives you 0, and therefore the line is horizontal. Does anyone know what it means by having 0 for a y value in this equation? There's no rise in this line, and like the floor, we could just walk and walk and walk, and we would never get any higher up than we were when we started. Just the opposite of the horizontal 0 slope is the vertical undefined slope. Plugging in the points, 3 minus -1, or 3 plus 1, divided by 3 minus 3 gives us 0. We get 4 divided by 0. We all know that no fraction can have 0 in the denominator, and therefore the slope of the line is undefined, and the expression 4 divided by 0 has no meaning. The resulting line is vertical, and we can compare this to trying to walk up a wall. It's impossible. Here we're going to have a recap of all the lines we just looked at. Positive slope rises from left to right. Negative slope falls from left to right, or rises right to left. 0 slope, which means there is no slope in the numerator, gives us a horizontal line. And undefined slope, which means there's a 0 in the denominator, gives you a vertical line. Slope is just one part of the line. Now we're going to look at the equation of the line as a whole, and that is called slope-intercept form. The equation for slope-intercept form is y equals mx plus b. M and b are constants, and we know that m is the slope and b is the y-intercept. The y-intercept is going to be the point where the line crosses the y-axis. The bigger the slope, the steeper the line, which is why when we get a negative slope, the line begins to fall down instead of rising up. We know the technical definition of slope, but what is really important to realize is that the slope is a constant rate of change in the line. We can prove this by showing that no matter what 2 points you choose, as long as they are on the same line, the slope of that line will always be the same or remain constant. Here's another example. This time we will graph the line using the slope and y-intercept. First we need to put the equation in y equals form. Y equals mx plus b. So we're going to subtract 5y from both sides. 3x minus 15 equals 5y. Next, we're going to divide both sides by -5, and now we have the slope-intercept form. Y equals -3 over 5x plus 3. To graph the equation, we look first at the y-axis and plot the y-intercept. Go up to y equals 3 and put a point. Then, to graph the slope, we count down 3. Since the slope is negative, and to the right 5, put a point there. If you wanted to continue the line, you would count down another 3 points, and to the right 5, and draw another point. This is the line y equals -3 over 5x plus 3, which falls from left to right because there's a negative slope. Here's another example of slope that you might find in everyday life. When you lean a ladder against a wall, do you think about the slope that it makes in proportion to the wall and the ground? Here, the top of the ladder is 12 feet from the ground, and the base is 5 feet from the wall. What is the slope of the ladder? Rise over run tells us that the slope is 12 over 5. Here's an activity to help you practice slope and to realize the relationship for the slope of a line between the points. Read the directions and go ahead and take a few minutes to answer the questions. What do you notice? What conclusions can you draw? We will look at the answers on the next slide, so when you're done, just put down your pencil and sit quietly. Okay, so what do you notice about the slope between the points? Between each set of points, the slope is 1/2. Therefore, we can complete the sentence. They are always the same, always 1/2. This proves that no matter what pair of points you choose on the line, the slope remains constant. Finally, we've all driven up and down a hill in the car with our parents. Wouldn't it be cool to know that you can figure out the slope that you had to drive up to the top? Use this example to find the slope of the road and keep this in mind the next time you go for a ride in the car. First, the slope of the road is the vertical rise divided by horizontal run. If the vertical rise is 24 feet for a horizontal run of 1 mile, what is the slope of the road? Now there's a trick to this problem, and it is going to be that they give you 2 different measurements instead of 1, feet and miles. You need to translate the miles into feet in order for the problem to work. 1 mile is going to equal 5,280 feet, so now you can just plug that number into the equation and come up with the correct answer. 24 feet divided by 5,280 feet reduces to 1 divided by 220. That means that for every 220 feet you go forward on the road, which is the run, you are also moving up 1 foot, which is the rise.